Here we're going to look at the graph of y equals mod x. We have a table of values. If x is minus 3, then mod x is 3. If x is minus 2, mod x is 2. If x is minus 1, mod x is 1. If x is 0, mod x is 0. If x is 1, mod x is 1. If x is 2, mod x is 2. And if x equals 3, then mod x is 3. Let's first draw the graph of y equals x. If x is minus 3, for y equals x, y is minus 3 as well. So we have minus 3 minus 3. We then have minus 2 minus 2, minus 1 minus 1, 0 0, 1 1, 2 2, and 3 3. So this line is the line y equals x. Of course, we should always label any line that we draw. Now to draw y equals mod x. When x is minus 3, mod x is 3, so we get minus 3, 3. We get minus 2, 2, minus 1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. We can now draw this. It's a V-shaped graph, and of course we should label it. If we now consider the graph of mod x, we can see to the right of the y-axis it's the same as y equals x. So we can write that the function mod x is the same as x, provided that x is greater than or equal to 0. If we now look to the left of the y-axis, this part of the line is part of y equals minus x. So we can say that mod x is minus x if x is less than 0. If we now perform a comparison of y equals mod x with y equals x, we can see that where y equals x was above the x-axis, mod x was exactly the same. However, where it's below the axis, we end up with a reflection in the x-axis. So this appears to be the case for modulus functions. Any part of a graph which is above the x-axis will be the same for the modulus function. Any part below will be reflected in the x-axis.